And here's the other thing. You say it all it takes is one, but I can come up right now with a probabilistic estimate, the Fermi paradox solution called the Drake equation. And it has all these terms in it, but there's one term that we have no idea about, which is how long does a civilization last for? All right. Well, I got to head uptown. I'm going to head out tonight to an event where I'm going to be talking about these meteorites. Again, you can get them on my website. But next time I want to talk to you about something really cool, because my next book is going to be about this magical person who brought me to New York City this time, Jim Simons. So Jim Simons was kind of like my scientific godfather, mentor. He happened to be one of the richest guys in the world. But he was also one of the most curious people in the world. He invented things in mathematics that have applicability, everything from genetics to quantum computers to cosmology to string theory and beyond. And he was, up until his dying day, he basically was commanding me, issuing me challenges to go out and discover this phenomenon, which is related to this magic crystal. So I kept teasing the magic crystal. So you have huge retention. This video is going to have like a flat retention curve, 99%.
Look at you little YouTuber.
Come on, you know I got to YouTube it up. So take a look at this thing here. Here's my card. This is you get when you get onto my mailing list there. So take this.
This is like a Costco lifetime membership card right here.
Yeah, that's pretty nice. So now put this magic crystal in, which is mostly clear, right? You'd say it's got some little cracks in it, but take a look and tell me, describe for the audience listening, perhaps when you put it over some text, what happens to the text?
Gets a little foggy.
Okay, so put it down flat. Put the card and the crystal down flat. This is called Icelandic spar, or
now it doubles it.
Crystal. It doubles it. Perfect. Yeah. This crystal is called birefringence. Bi, like bisexual.
I can't decide. Yeah.
Yeah. Bicycle. Birefringent. It has two refractive indices, two different directions for light to propagate in. Your glasses have one. If you had glasses made of this stuff, you go nuts. Now, this is a polarizer. What I have here is called an optical polarizer. What it's going to do is kill off one of those two polarization states that have different indices of refraction. Tell me what happened. Put the card, you guys fidget too much.
Put it flat?
Put it flat, put both of them flat, and now put that on top
separately?
of it.
Or on top of it?
Well, you put it separately first just to show that it doesn't do anything. It just makes it darker, right?
It just makes it darker.
So on your cameras right now, you don't have any ND filter. Shame on you, Joe. Shame on you.
What's an ND filter?
ND filter,
That'd be
Joe,
my fault, not Joe's.
What's that?
Yeah. What's an
That's
ND
a
filter?
neutral density filter, so it allows the aperture to remain open more, so you get a little more motion blur. It cuts down on the intensity by a certain
hope you know
power.
what he's talking about.
Yeah,
all right, good.
There are other ones called circular polarized filters, and then there are ultraviolet light filters. It's a good tip out there for expensive lens, kind of whores like me. There's a beautiful camera shop around the corner. It's amazing. You should go take a look.
Well, we got B&H on 34th over
It's
here.
over here too?
Yeah,
okay.
yeah.
Gotta check them out. Baruch Hashem. I gotta go check them out. So when you look at that through the polarizer, it just dims everything. That's all it does, killing off half the light. Now, if you put it on top, and now you might have to rotate the circle, the polarizer.
No, it's all single.
And now it's making it single. So it's killed off one of the two images that was distorting the view that you have of the card. In the cosmos, there have been claims that the universe does the same thing as that crystal. In other words, it appears as if the universe, according to researchers using data from the Planck experiment, that there's a delay or there's a slower propagation of light. Like Claudia thinks for gravity, but this is for light. Light may slow down slightly based on its polarization. That is an idea that is related to what Jim Simons invented called the Chern-Simons topological invariant. What we're looking for at the Simons Observatory is to determine whether or not we can see this. It's called cosmic birefringence. Birefringence is the double refraction. Why you saw two images. The polarizer kills one of them, allows you to see clearly in one light only. Now, one last experiment you could do there, and this is actually what we're doing at the Simons Observatory. So put the card, put the crystal, the birefringent calcium crystal, put that on top of the text. Put the polarizer on, it kills it off. Now rotate the polarizer about its center and tell me what happens to the letters that you see. Just keep the crystal on the card fixed.
So just rotate it like this.
Just spin it. Yep. What do you see happening?
They get darker.
It gets darker, and then it gets lighter, and you can see it again.
Yes.
That's called modulation. What you're doing is you're changing.
Oh, and they change positions.
Change positions, right? So you're basically killing on. Isn't that
my
cool?
ADD is going to go nuts.
It's pretty
with this
wild,
later.
right? This is incredible stuff. This is fundamental physics. To determine if, on cosmic scales, if the universe behaves as if it's filled with this crystalline refractive index material is one of my top goals, because it turns out to be related to properties of dark matter. It could be that what we call dark matter, It's just what's called a heavy photon, a photon that actually has mass, but we've never seen it because we've never seen far enough back that the effects, this is a huge effect here. I mean, you could see it with your eye basically, but imagine if the effect is like parts per trillion. And we've never been able to look far enough into space until now at the Simons Observatory. So this, one of the goals of the Simons, the one I'm most interested in because it was the one that Jim Simons thought. This is a guy who had a mega yacht, had a G650.
He was a hedge fund guy, right?
He had started a hedge fund and he had run it and the most successful. Then he pivoted. So this is his career. He's a mathematician. He's the first chairman of this SUNY Stony Brook math department, which is where he hired my father. And so they were colleagues, and that's how I got to know him. He hired my father. My father was a professor at Cornell. He moved down to work with Jim at Stony Brook.
Yeah, he died last year.
He died a year ago. And that's why tomorrow is a memorial kind of tribute to him, where we're going to have some of the greatest physicists, Nobel Prize winners. And
just ripping bogues till the end. God
he
bless
actually
him.
was, he smoked Merit, filterless usually for 65 years. He died May 10th. Yeah. So tomorrow we're having an event for him where we're honoring his life, his legacy, his scientific contributions. But one of the ones that he always kind of wanted is he had the 650, he had the limo, he had the Gulf, he had the mega yacht, but he won a Nobel Prize. It's really funny. The man who had everything. I got him an asteroid. I have an asteroid named Jim Simons after him. If
that's right.
On Wikipedia, you'll probably find it there too.
That.
6618, Jim Simons.
I didn't know until Eric went on with Rogan back in February 2023 in that episode where he's like, Michikaku's out of control. But like he talked about this guy, and I really never knew about this guy before.
He is a fascinating. Yeah, Eric, projects a lot of stuff onto him. Like maybe he was involved in gravity research and funding like super secret technical organization near Brookhaven National Labs in Stony Brook, and the hedge funds a CIA cover. Yep. I don't agree with him. I mean, he told me, and actually on my podcast with him last month, he said that, Jim told him that it was actually much more boring than he suspected. And I knew that because he had told me that the secret
that's what
that they
I would
had.
tell him too if I was working for CIA.
Yeah, but if it's hard, again, it's hard to have a conspiracy, a cover up, whether it's about assassinations, whether it's about UFOs, or whether it's about CIA, involvement in a math department. It's maybe you can control it over one or two guys or gals, but then their spouses, their kids, they want to put something in their will, they want to do, and they have to be verified. Right. So that's what they say. They say two people can keep a conspiracy if one of them's dead.
That's right.
A famous.
This isn't hard. Come on.
Famous saying, right? So. Anyway, the next time I come back, I hope that we'll have information that either refutes the claim made by, quite frankly, their kind of competitor. I mean, I've been looking for this signal. They claim they detected it using this $1 billion satellite called Planck data, and they're great scientists. And I'm kind of trying to see if they're right or wrong. And I've been working on this for a long time. But no matter who's right, we want to know the answer. And so I'm comfortable being wrong. But if it does turn out to be there, it would be incredibly ironic because it would mean that Jim Simons, beyond the grave, is now experiencing this Nobel Prize worthy discovery that only he was legitimately responsible for, both in terms of funding the observatory, funding the team, funding the basic scientific research, and providing the inspiration to millions of people to be fascinated with stuff in the cosmos for the betterment of mankind. Really, he's like a modern day Alfred Nobel, or was.
Can you get a Nobel Prize posthumously?
No, that's one of the problems that I wrote about in my book, my first book, Losing the Nobel Prize. It's about how it's cruel, unfair, and inaccurate description of how scientific method works. It doesn't work that way. Science is not about like, oh, you happen to be alive when this thing came. No, what matters is like we still use Newton's laws over certain ranges, and then someone comes along and shows that Newton's wrong, named Albert Einstein, and then someone will come along later on and prove that Einstein's wrong, and that actually, Claudia or somebody else.
That's how it works. That's how it's supposed to work.
And my job as the experimentalist is to provide the data that then discovers or refutes what they claims are being made, and hopefully gets us on a pathway that's closer to the truth.
As we see farther away, last question for you. As we see farther away, though, we're talking about distances today that just blow my mind, and obviously the exploration aspect of science is moving up at a fast rate. As we look farther away, though, and begin to actually conceptualize just how many galaxies there are, or that we didn't know about before, or how much matter or lack thereof might be in some of these, mathematically speaking, doesn't it start to make the possibility that the probability that there is intelligent life out there, meaning like an alien as we would consider it here, doesn't that make it damn near 100% as we get farther and farther here?
I don't think so. I mean, I've had this debate, again, going back to Antarctica. So when I was in Antarctica, I think at one point in time, I was probably the most overweight person on the entire continent. You know, 25% body
people
fat.
There?
Well, no, that's the point. Yeah, it's a huge amount of space, though, which is basically the argument you're making. Space is proportional to content, right? So, like, just because you have a lot of space, like, there's an awful lot of, of hard disk space in the cloud, so to speak, right? Does that mean it's all filled up? There's a lot of content on there, too, but it's a fraction of what there could be. On Antarctica, right now, in the middle of their winter, it's actually going to be the coldest night. It's going to be about 100 below zero Fahrenheit. So, on July 4th every year, they do what's called the 300-degree club. They go outside, they go into a sauna. There's a sauna at the South Pole that goes up to 200 degrees Fahrenheit. Then they go outside for the ultimate cold plunge, except they don't lie down. They run around. You can only wear your shoes or else your clothes will freeze to your body and freeze off your junk. So they go out from 200 degrees positive to negative 100 degrees and run around the South Pole, which is just like a flagpole, basically. And then they come in. That's called the 300-degree club, experiencing a delta temperature of 300 degrees Fahrenheit. Insane. You can't imagine it. If you spit, your spit freezes in midair. Your eyeballs could freeze in midair. But anyway, that's a tradition down there.
Who the hell wants to do
Antarctica,
that?
there's right now 40 people there. So it's a continent. It could support billions of, literally every single person on Earth could fit in a 1 cubic mile cube. Did you know that? If you took everybody on Earth, put them in a blender, they fit in 1 mile, a cube from here to Manhattan. Blender. Well, don't put them in a blender. They fit in a 2 cubic mile. I mean, how big do you think you are in a blender versus, fully extended? Maybe 2 miles. Does that make it any less tiny compared to the size of the Earth? There's almost nobody on Earth compared to the size of what the Earth could support. So you telling me the universe has a radius, which we know to be true, of 45 billion light years. I mean,
we know that to be true.
Yeah, that's how far away the CMB is. That's where the CMB last scattering surface that you talked about in timestamp 2 hours and 14 minutes with Claudia Durham comes from. Don't you remember? Do I know your timestamps better than you do?
On this count, you do. That's a first in the history of our show. Nice job.
So when you look at the universe, you see how what we're observing, again, could not be there. Like, these things could have disappeared. So I like to, let me even just spot you all that. Let me just say, in our galaxy, let's just focus on things that plausibly could have come to Earth in the 30,000 years since human beings in modern form came about in, the Mesopotamian region of the Middle East, right? 30,000 light years away. And traveling at the speed of light, and they got it. That's a volume about the size of our galaxy, okay, or an area the size of our galaxy in radius. In that regime, we have zero evidence, even though there's literally 100 billion stars in our galaxy. Each one has maybe 10, 100 planets, just like ours does, right? Minor planets, big planets.
All it takes is one, though, Brian. All it takes is one planet that has intelligent life.
But there's also zero evidence for any of them to be there. So if you have something that says that you can have this, like, again, perpetual motion machine, or you have some symmetry principle that says that there's no possibility whatsoever of getting some angular rotation that doesn't produce what's called angular momentum. Like, there are things in physics called conservation of energy, right? So all it takes is one. Well, all it takes is one violation of conservation of energy. Yeah, but we've never seen that. We have no evidence for that. We have principles of physics that are based downstream on that, of not occurring. And here's the other thing. You say it all it takes is one, but I can come up right now with a probabilistic estimate, the Fermi paradox solution called the Drake equation. And it has all these terms in it, but there's one term that we have no idea about, which is how long does a civilization last for? So even let me stipulate that there's been millions of civilizations, but our galaxy is billions of years old. So that means if each one doesn't last for more than 1,000 years, which, I mean, what would you put the odds of humanity existing right now in 2025 for another 1,000 to 10,000 years?
The odds?
Yeah.
At 1,000, I'd say the odds are excellent. At 10,000, it gets dicey.
I think Musk would say the odds of 10 years from now is pretty low, or else why would he put all his money into it? If you told
10
Elon,
years?
Well, why is he building rockets on a timescale to get to Mars in 2035?
I know, but that seems a little doomer. 10 years is crazy.
Oh,
You're
so
talking about
20 years.
civilization collapse?
He obviously thinks that there is some urgent reason to go to Mars now. Rather, look, if you try to invent the iPod in 1985, you probably could have. I mean, there were hard disks back then. Okay. There were certainly Walkman. I had a Walkman probably before you were born. And so you could have put one together. It would have cost $1 trillion, right? But if you waited until, okay, now they shrank down to 1-inch diameter disk drive that could fit 1,000 MP3 files, and you waited for the MP3 compression algorithm to be invented, now it's much easier for you to invent the iPod, right? So why do you don't want to do things now? In fact, Steve Jobs famously said, like, I don't give away money now, because if I give away $1 now, that's $100 I don't give away when I die. And he gave away all his money when he died. And some people think that's illegitimate, and some say it's not a good way to give charity. I'm not going to comment on that. But the point is, it's always easier, it gets faster. Moore's Law, just think about Moore's Law. If you try to invent an iPhone today, you could not do it. I mean, an iPhone 100 years ago, you couldn't do it. But if you wait 200 years, it'll be like, we literally do things in our lab classes that won Nobel Prizes 50 years ago. In other words, technology, instrumentation, analysis, compression, algorithms, computing, all these things are going to make things exponentially easier. So why not just wait? The answer is he doesn't think we're going to last that long. He legitimately thinks we need to get to Mars and back up the hard drive of consciousness in the next decade or 2 decades. Now, you can argue with that, but it's certainly not, you couldn't convince me that he thinks 1,000 years from now, meaning that he doesn't think consciousness to flicker will be not extinguished 1,000 years from now. You seem to be more optimistic. I'm not going to argue which way or another, but the point being, you have to make this estimate. But the fact that you and I can't really agree on it, he maybe disagrees with both of us. The fact is, that just points to the fact that even if there was a technological civilization with opposable thumbs that can make an iPhone, that can make that we don't know how long they could last for. They could last for a year, they could last for 1,000 years, but they probably don't last for millions of years. So they're either there, they were there and they're dead, right? Or they're coming in the future, right? After 1,000,000 years more of evolution, and maybe they're watching us or doing something else. But just the mere fact that space is big has no bearing on the probability of life existing elsewhere on let alone technological.
I would say if that's the only variable you're looking at it through, that would be correct. However, when you start to look at the existence of these other stars, and then you consider what we don't even know about our own planets in this little solar system right here, and now extrapolate that across, I'll just say thousands, but it's probably more, thousands of other solar systems that could exist. Again, that's where it starts to get
to me. I've heard this argument many times, but it's kind of like a gambler's foul. Like, okay, so it's only worked here, but it's got to work somewhere else because there's so much time has elapsed and the universe is so big. But all those things. If I told you this, we wouldn't be here if Jupiter wasn't about the size that it is right now. We wouldn't be here if the moon wasn't exactly where it is with the exact same size that it is. Forget about us going to the moon. Okay, so and now you ask the probability. How many different things are responsible for our existence? Going back just in our solar system. So like the position of the moon, the size of the moon relative to the Earth, the size of Jupiter and the other outer planets, that there aren't other ones. Most stars in the galaxy are double stars. We don't have a double star. That makes things easier for stable orbits to develop, and so on. And we also were hit by a massive asteroid called Theia back about 4.5 billion years before. That's where this asteroid fragment, the meteorite, comes from. It comes from that huge collision of the pre-existing solar system. If that occurred after, say, the moon had formed, we wouldn't be here. The moon wouldn't have formed, and probably would have been obliterated the Earth-Moon double planet system. If the comet that hit the Yucatan Peninsula, killing off the dinosaurs, if that occurred before the asteroid that hit the Earth or pre-Earth that formed the moon, if that happened before and didn't kill off the dinosaurs, we wouldn't be here, right? Because the dinosaurs would have outcompeted us.
That's
and we couldn't survive. So all these different collisions. And lastly, there are things called the comets that provide the water on Earth's oceans. If those came before Theia or before or after the dinosaurs, wiping asteroid, we also wouldn't be here. So there's 3 different types of collisions. They had to happen in exact right order. They had to occur in the exact environment of our solar system, when afterwards there were, before which there were oxygenation of microbes, and afterwards there were prokaryotic or eukaryotic cells that had cellular membranes. All these things, any of them change in order. That wouldn't have, now this could be used and distorted as argument for God or design. I don't think that's relevant. We're just talking about life, intelligent life, all these variables. Just take 10 of them and say each one has a part in 1,000 of occurring, which I think is very low. I mean, the odds of the asteroid hitting the Earth, proto-Earth, and forming the moon coming before the asteroid that killed the dinosaur, that's like 1,000,000,000,000 to 1 odds, but let's just call it 1,000 to 1 to make it as favorable as possible for you. Now take 10 different things: size of Jupiter, distance of the moon, formation of the moon before, after the formation, before the formation of the dinosaur killing asteroid. Get 10 of those things. Each one is a part in 1,000. You get 10 to the 1 over 10 power. So you take 1 over 10 to 10 to the 30th power. 1 in 10 to the 30th. There's only 1 times 10 to the 24th stars in the entire observable universe. Yeah. In our galaxy, there's 10 to the 12th, or at most, stars in our galaxy, maybe even 10 to the 11th. So now you take those, that means it's 1 in a trillion odds that we're here. Okay, so that we are not alone. So these are just, I mean, astronomical numbers. It's very hard to multiply large numbers by almost infinitesimal numbers. You can get any answer you want. And so because of that, I don't like the argument that, oh, space is very big and therefore there has to be life. There's no evidence for that. It sounds good, feels good, doesn't pay the bills.
There's a lot to dig into there, but I know you got to leave, Dr. Keating.
Chapter 3.
We will definitely do
When
that
you're
in
at 2
chapter
million.
3. Yeah. I like the way he's thinking. But listen,
right.
I love talking with you, Brian.
Yeah, it's fun.
It's a lot of fun.
Thanks for coming
And
around.
you got a lot on the bone there that you're always looking at. You're also one of the most connected guys within the physics space I've ever talked with. So
That's
I know
fun.
you're talking to a lot of different perspectives. So thank you as always
fun,
for
man.
stopping by.
Thank you for hosting me.
All right. And we'll have the links down to your YouTube
Get the
channels
meteorite. Yep.
below. And then
that's right.
we should put your website down there too,
Yeah,
right?
briankeating.com.
You got it. All right. Everybody else, you know what it is. Give it a thought. Get back to me. Peace. Thank you guys for watching the episode. If you haven't already, please hit that subscribe button and smash that like button on the video. They're both a huge, huge help. And if you would like to follow me on Instagram and X, those links are in my description below. Thank you guys for checking out this clip. If you haven't already subscribed, please subscribe and hit the like button on this video. It is a huge, huge help. And if you'd like to check out this clip's full podcast episode, that link is in the description below or right here. And finally, you can follow me on Instagram and X by using the links in my description below.